So, integrating this expression, still using the b instead of the square root of mg over gamma. This is clearly the integral. The steps are simple. And I don't add the integration constant here because I'm going to be integrating both sides of the equation. Yeah.
I thought adding was multiplication. And subtracting.
Well, yeah, but you got a negative in this one.
Ah, yeah, my bad.
Yeah, see, factor out the 1 over 2b, and then it's this over this minus this over this, right?
Yeah, good deal.
So you're right. If you work through the details, so you're going to see that because you knew what you were saying.
Yeah.
You know the laws for logarithms. Okay? So we get, and I'm skipping a step, but the integral of dv over b squared minus mg over gamma equals gamma over m dt ends up through this whole process giving you this on the left-hand side where b is the square root of mg over gamma. Okay? So on the left-hand side we get the natural log of the absolute value of v plus the square root of mg over gamma divided by v minus the square root of mg over gamma. And that's going to equal, okay, well it's going to equal, notice I don't have the 2b here. Yeah.
You got them backwards. It's 1 over 2b, b minus b. A was over b minus b, and b was over b plus b.
You're right, I had it minus here and plus here. Okay? So, yep, we make that correction. I even looked to see which way I had it, and then I wrote it down the opposite way. Okay? So we should have had the minus here and the plus here, which is going to put the minus here and the plus here. So, that makes up for thinking that this was an addition. But again, with your excellent attention to detail, you wouldn't have missed that anyway.
Redemption.
Okay? Okay, so again, this integral becomes this. I don't have the 2b over here because I'm going to put it on the right-hand side. But b is the square root of mg over gamma, right? So that's going to be 2 square root of mg over gamma times gamma over m times t, and there's our integration constant on this side. Now we're kind of on familiar ground here, except that this term's a little more complicated than what we're used to. We exponentiate both sides, and we find that v minus the square root of mg over gamma divided by v plus the square root of mg over gamma equals a e to the, okay, now, you know, we got a gamma over m here and a m over gamma here under the square root. So we're going to have 2 times the square root of gamma g over m times t, if I did that right. Okay, because it's like if we got a gamma over m here and we'll put that inside the square root, we're going to have to put a gamma squared over m squared here, right? And then the m over gamma will take care of the square, and we're just going to end up with a gamma over m, and that's straightforward algebra. So yeah, think it through if you need to. Okay? Okay, well, that's great, but we got to solve this for v. And then we got to use that solution. Now, I just repeated essentially what we did about a week ago. Okay? So as a result, we didn't get to, and we're out of time, but yeah, we didn't get to talk about how you put the initial conditions in here. Okay, of course, I didn't have initial conditions in this problem. Again, I'm just illustrating the problem we would get for free fall and the technique that we would use when this thing gets complicated by the constant term over here. Okay? In the first problem we did, we just had a gamma v squared here, right? So it was straightforward to separate it, integrate it, and get the solution for v. So you need to compare solutions of this nature with solutions of that nature. Okay, quick, well,